Hello there, this is GeeklyEDU, and today we will continue with the derivative of some functions. In previous videos, we studied the mathematical definition of the derivative and proved some of the basic rules of the derivatives. Using that information, today we will see the derivatives of trigonometrical functions. Let's make a quick review. The derivative of a function is another function that describes the rate at which the dependent variable changes with respect to the independent variable, and it is represented by the limit when h tends to 0 of the function evaluated in a point C plus h minus the function evaluated in the same point C, all of this divided by h. Let's calculate the derivative of the sine function, using the definition of the derivative. The first step is to evaluate the sine function in the definition. And using the trigonometric identity for the addition in the face of the function, we can substitute sine of x plus h. Then, we factorize sine and cosine of x and evaluate the limit when h tends to 0. The first parenthesis when we evaluate the limit is equal to 0, and the second, by using the rules for the limits of sine, is equal to 1. Therefore, when we multiply sine of x by 0, that term is equal to 0, and the cosine of x by 1 is equal to cosine of x. Finally, we get that the derivative of the sine function is the cosine function. Representing the function sine and the derivative of the function cosine of x, we can see the rate of change of the function sine depending on x. In this graph, the blue line is the function sine and the orange one is the derivative of it, cosine of x. Using the same method, we can know the derivative of the function cosine, first evaluating the function in the definition of the derivative. This time, we are using the trigonometric identity for the addition in the face of the cosine function. The next step is to factorize the terms with an x and evaluate the limit when h approaches to 0. When we multiply cosine of x by 0, the result is 0, and minus sine of x by 1 is equal to minus sine of x. And we obtain that the derivative of the cosine function is minus sine of x. The representation of these two functions is shown in the graph, being the yellow line the derivative of the cosine function in blue. To calculate the derivative of the other trigonometrical functions, you can do it by using the definition or by rewriting the trigonometric functions in terms of sine and cosine functions, and using the rules we studied in the last video. Meanwhile, I will give you the rules and the graphical representation of those. The derivative of the tangent function is secant squared, and the derivative of secant of x is the product of secant and tangent. Now, the derivative of cotangent is minus secant squared of x, and finally the derivative of cosecant of x is the product of minus cosecant and cotangent. To finish this video, we are going to solve one example that involves three of the trigonometric functions and the rules of the derivative. Being f of x equal to sine of x plus cosine divided by tangent, we can rewrite this expression by decomposing in two different fractions. And by the trigonometric identities, we know that sine divided by tangent is equal to cosine. Now, it is a little easier to calculate the derivative of this function by using the rule of the addition that says that the derivative of the sum of some terms is the sum of the derivative of those terms. The first one is easy. The derivative of cosine of x is minus sine of x. And for the second term, we will use the quotient rule. Here is a rule if you don't have yet your formula sheet from the last video. Well, we have that the derivative of cosine is minus sine, and the derivative of tangent is secant squared. Simplifying this expression by using trigonometric identities, we have that the derivative of this quotient is minus cosine of x minus cotangent of x cosecant of x. Therefore, the derivative of the function sine of x plus cosine of x divided by tangent is minus sine of x minus cosine of x minus cotangent of x cosecant of x. The graphical representation of the exercise is shown, being the blue line of the function sine of x plus cosine of x divided by tangent, and the orange line its derivative. This will be everything for today. I'll leave you with a second sheet of the derivative rules, and tell me in the comments below if you think if all the functions can be derivated. I will tell you the answer in the next video of continuous and discontinuous function. So subscribe to our channel so you don't miss any video, and don't forget to like this. Thanks for watching and see you soon!